In question 6, we have these patterns. So the consistency is this block in each one. So we have one block, then we have a 1 by 1, then we have a 2 by 2, and then we have a 3 by 3. So let's look at some of the questions here. So there are 2 cubic bricks in T1 and 9 cubic bricks in T2. How many cubic bricks will there be in each of the first 6 terms? So we want the first 6. So you can see the 9 here. We can see 1 and 1. And then we have, it's a 2 by 2 by 2. This one is a 3 by 3 at the front, but we also have 3 layers of that going backwards. So that's going to be 1 plus 27. Or 1 plus 3 cubed. This is 1 plus 2 cubed if you try and see the pattern. This will be 1 plus 1 cubed. We don't need the cube part. So the first 6 terms, okay, we'll write them over here. So we're going to have 1, we're told 9, 2 cubed is 8, 3 cubed is 27, add your 1. 4 cubed is 64, and add your 1, and 5 cubed is 125, add your 1, 6 cubed is 216, and add your 1. Write down the first, second, and third differences. Okay, let's write down the differences here. We have 8, we have 19, we have 37, 61, and we have 74 and 17, 91 it looks like. You can always go back and check, see if you made a mistake. The second difference is going to be 8 to 19, 11. 19 to 37 is 18. 37 to 61 is 24. 61 to 30, 61 to 91 is 30. So you can see we've made a mistake here. So they should all be 6. The second differences, as you can see here, 6 and 6. The third differences. So what mistake have we made here? You can see it's that the first term should have been 2. This should have been 7. It's just an example of a mistake that it's easy enough to spot as you move down the question, and that should be 12. So we have our third difference. Is it linear, quadratic, or cubic? Well, it's cubic. Third difference is the same. Now 2a in quadratic sequences, 2a is equal to the second difference. 6a in cubic is equal to the third. We'll use this going forward. How many terms in this sequence are less than 1 million? So what we need to do here is find the sequence in terms of n, tn. We kind of have it already. It's 1 plus n cubed, isn't it? 1 plus 2 cubed. So it's n cubed plus 1 is the sequence. And how many terms in this sequence will be less than 1 million? This will have to be less than 1 million. We find which term is 6 zeros. So n cubed would have to be less than 999,000. 999,999, comma in the wrong place. And if we get the cube root of 999,999, we're going to get just less than 100, aren't we? You can see here 999,999 equal to 99.99. So the 100th term will be greater than 1 million, so 99 terms will be the answer here. Question 7 is another quadratic sequence dressed up as a car being a distance from a marker. So we have the sequence here. So 7, 27, sorry, 17, just checking here, 7, 17, 27, I'm looking at the third number. And then 30 seconds, 37, so we can see the second difference is 10, so 2a is equal to 10, a is equal to 5, you may as well just finish getting your a, b, and c. Term 0, I'll put the term 0 here, so 37, 27, 17, 7, this will be taking away 10, we would get to minus 3, So we'd have 12 minus 7 is 5, and 5 minus 3 would actually be plus 8. So C is equal to 8. And A plus B plus C is equal to term 1, which is 5. So B would have to be equal to minus 8 here to get our 5. A and C is 13. 13 minus 8 is 5. Okay, so we have Tn is going to be 5n squared minus 8n plus 8. So let's check the third one. Should get 29. So T3 is equal to 5 by 9, 45 minus 24 plus 8, which is 53 minus 24, which is 29. So yes, we're correct. So we've actually done most of the other parts. We haven't done the next two terms, but you can see here you can get them quite easily. And then we found K to be C, just in a different context, and T10, just put 10 in. T10 is going to be 505 by 10 squared minus 8 by 10 minus 80 plus 8, which is equal to 420 plus 8, 428 for question 7. So you should be masters at these quadratic sequence questions at this point.